The simplest way I can explain regression is it's basically the modeling of two variables to predict the value of one variable by fixing the other variable constant. Okay, one of these will be dependent, one of them will be independent. We fix the independent and we look for the dependent value, which is usually the y value. So in this case, we have time of day and evaluation papers done in a day for our x and y values. Now in this graph, they should actually be flip-flop, but let's just assume they're flip-flop at this point. Okay. Now this u value will represent our expected value of our scatter plot here. We plotted a scatter plot. And these points here are expected values. These are expected values here. Now the difference between the expected values and our observed values is going to be our epsilon. Okay, and I'll explain that on the next slide a little bit. Epsilon is basically the error due to our observed and our expected values. Okay, so the closer epsilon is to the actual true regression line, the more perfect our linear relationship is. And the reason why it's not perfect is because there's a thing called non-determinism in regression. And what it does is the y value is never perfectly determined by the x value. Okay, there's always a bunch of other factors. There could be friction on the road. There could be a dead rodent there. Okay, so maybe the speed isn't perfect. It isn't a perfect approximation for the distance. Okay, but if we look from a probability standpoint, because we assume it's linear, we assume it's almost perfect, we can plop a distribution of E onto that graph, or epsilon on that graph, and we can use our p-value skills to find a probability for what y value we want to get. It's as simple as that, and that's linear probability in a nutshell. But let's move on to a practical example here. So here we have the presence of bacteria in the billions for a line fit plot. Now this is very similar to the first slide we had. So one of the things we can do with regression is we can figure out how much the dependent variable changes with a change in the independent variable. So how do they change in tandem? Are they close? Are they, I don't know. That's what we're trying to figure out. So how much does the bacteria affect the concrete barrier's integrity in a way? Another thing we can do is figure out the strength of it. So like if we have 2 billion bacteria, are we going to have 4 centimeters? Are we going to have 6? Are we going to have 8? Are we going to have 10? I don't know. Does it change by 8? Does it change by 4? That's what we can determine. And one of the most important things we can do is we can predict trends and future values. Okay, so say we wanted to know whether the the future value is going to be greater than the value came before it. We can figure that out using our p-value skills, like we said before, because we modeled this as a linear relationship. Now, but the problem is answering any of the above questions requires that we know how to calculate the parameters of the regression lines, which is in the next section of this I'm not covering today. But we can get a general idea how simple regression works. And based on later things, we can also check how good that regression is as well.